Hello children, now we will start with part 10 of data handling. In this part, we are going to do few examples on probability and then start with exercise 5.3. I hope you are clear with what is probability and you are now familiar with the terms like outcome, random experiment, favorable outcome, events, and what are equally likely outcomes. I also hope that you remember the formula for finding the probability. If not, again go through my video of part 9 so that you are first clear with all these concepts. Then only start with part 10 of data handling. So let's begin with the example based on probability before starting with the exercise. A bag has 4 red balls and 2 yellow balls. A ball is drawn from the bag without looking into the bag. What is the probability of getting a red ball? Is it more or less than getting a yellow ball? Children, here we will follow a pattern, and for every sum where you have to find probability. Always first write down total number of outcomes, then write down probability is equal to favorable outcome upon total outcome. This formula carries half mark. After that, you write name the event, that is, let A be the event. Here it is of getting a red ball. Whatever question you are asked, name that as an event of. So here let A be the event of getting a red ball, and you, in the bracket you write down which are the favorable outcomes, number of favorable outcomes. And so here P of A is equal to 4 upon 6, and that is equal to 2 upon 3. The simplest form you have to write. So I hope I am clear with what we have to do. So here also total number of outcomes, there are 4 red balls and 2 yellow balls. So you will add that 4 plus 2 is equal to 6. These are the possible outcomes. Then you write the formula for probability and then let A be the event of getting a red ball. Now there are 4 favorable outcomes because there are 4 red balls. So 4 times if you put your hand, you may get a 4 red balls. So that's why the favorable outcomes are 4. Now therefore P of A means probability of getting a red ball. We write this in short as P of A. We read it as P of A, and the meaning of it is probability of getting a red ball. So P of A is equal to favorable outcome is 4 upon 6 is the total number of outcome. 2 2s are and 2 3s are, so answer is 2 upon 3. Now the next one is it more or less than getting a yellow ball? Now first we will have to find the probability of yellow ball. Then only we can compare whether it is more or less. So let B be the event of getting a yellow ball. In the bracket you will write down 2 outcomes because they are the favorable outcomes and there are only 2 balls. 2 times you put your hand, you may get a yellow ball. The third time you will not get a yellow ball because there are only 2 yellow balls. So the favorable outcomes are 2. Therefore P of B is equal to favorable outcome, which is 2, upon total outcome, which is 6. So that is equal to 1 upon 3. Now 2 upon 3 is greater than 1 upon 3. Therefore, probability of getting a red ball is more than the probability of getting a yellow ball. Now we will start with example 4. A die is thrown once. Only once you are throwing a die. Find the probability of getting a prime number. So first you write down total number of outcomes, which is 6. That is, you either get 1 or 2, 3, 4, 5 and 6 on the top. So probability is equal to favorable outcomes upon total number of outcomes. Now let A be the event of getting a prime number. Now from these the prime numbers are 2, 3 and 5. So you write down 2, 3 and 5 are prime numbers. So which are how many total favorable outcomes? 3. 1, 2 and 3. So 3 favorable outcomes. Therefore, P of A is equal to 3 upon 6 and that is equal to 1 upon 2. This is the answer. Now let's start with the question 1 of exercise 5.3. List the outcomes you can see in this experiment. The first one is spinning a wheel. Second experiment is tossing 2 coins together. Now when you are spinning a wheel, you can get either this or this or this or this or this. That means the arrow may point at B or C or D or A or A. But here you don't have to list the total number of outcomes, you just have to list the outcomes. So outcomes in the spinning of the given wheel are A, B, C and D. I will not write A again because it is an outcome A. So we will not write the ones which are repeated, only which are the possible outcomes, not the total number of outcomes. So A, B, C and D. On tossing 2 coins together, the possible outcomes are, here the word outcome is missing, it's my typing error. So here on the first coin it may be head and in the second coin also it may be head. The first one head and the second one it may be tail. And the first coin it may be tail and on the second one it may be head. And in both the coins it may come out to be tail. So HH, HT, TH and TT are the possible outcomes. Let's go to question number 2. When a die is thrown, list the outcomes of an event getting a prime number and not a prime number. So I will just start with the first one. Total outcomes when a die is thrown are 1, 2, 3, 4, 5 and 6. So total number is 6. Now the first one, outcome of getting a prime numbers are, just the outcomes are asked. So these are the outcomes of getting a prime number 2, 3 or 5. Outcomes of not getting a prime number are, so which are not the prime number? 1 is a special number, 4 or 6. 4 and 6 are the composite numbers. Now let's go to the second question. A number greater than 5. You just have to list the outcome. So our outcome of getting a number greater than 5, there is only one number which is greater than 5 and that is 6. So you write is 6. And outcomes of getting a number not greater than 5, so you can get any of these, 1, 2, 3 and 4, they are smaller than 5. And this 5 is also not greater than 5 but it is equal to. So this is also considered. So 1, 2, 3, 4 or 5 are the outcomes of getting a number not greater than 5. Let's move to the third question. Find the first one, probability of a pointer stopping on D in question 1A. Now total number of outcome is 5. I told you whenever you are asked probability, you will follow these pattern. So total number of outcome is equal to 5. Then you write the formula, probability is equal to favorable outcome upon total outcome. Now let E be the event of getting a pointer stopping on D. Let E, you can give any name, any alphabet you can take. I can also write let M be the event or let P be the event. P we cannot write because we are using it for probability. You can write Q also. So let E be the event that the pointer stops at D. So that is equal to favorable outcome upon total outcome. Now you can see there is only one D. So the favorable outcome is one outcome. So P of E is equal to 1 upon 5. Now the second random experiment is probability of getting an ace from a well shuffled deck of 52 playing cards. So this is ace means ikka, and there are 4 ace in the playing cards, set of playing cards or deck of playing cards. So first, how many playing cards are there? 52. So you write down total outcome is equal to 52. Then we write down the formula, probability is equal to favorable outcome upon total outcome. And third thing is we name the event. Let A be the event of getting an ace. How many aces are there? There are 4 aces, and so there are 4 outcomes, 4 favorable outcomes. So therefore P of A is equal to 4 upon 52, which is equal to 1 upon 30. Now here, probability of getting a red apple. First, what will we write? Total outcomes. So how many are the total outcomes? 1, 2, 3, 4, 5, 6 and 7. So I write down total outcome is equal to 7. Then what do we write? We write the formula. So we write the formula, probability is equal to favorable outcome upon total outcome. What should be my next statement? Yes, let A be the event of getting a red apple. So we write let A be the event of getting a red apple. So therefore probability is equal to, after that, total favorable outcomes are 4. Now P of A is equal to favorable outcome is 4 upon total number of outcomes 7. This cannot be simplified further, so we will leave it as it is. So children, you complete till question number 3 in your notebook. We will continue with question number 4, 5 and 6 in the next part. Till then, stay home and stay safe.